There is a war happening inside your mouth right now. Not a metaphor, a literal biological conflict between bacterial colonies and the hardest substance your body produces. And most people are losing it slowly, without knowing it, without feeling it, until the damage has already been done for years. Dental caries is the most common disease on Earth, more common than diabetes, more common than heart disease, more common than any infection we track globally. Over 3 billion people are currently affected. And the way most people think about cavities, sugar touches tooth, tooth gets whole, is so incomplete that it explains almost nothing about how to actually prevent it. Today, BodyCode goes inside the mouth, not to the surface, to the molecular level, where a specific species of bacteria is converting the food you eat into acid, dissolving the crystalline architecture of your teeth from within, and doing it so gradually that your nervous system registers nothing until the destruction is already deep. This is the biology of dental caries, and once you understand the actual mechanism, everything you thought you knew about protecting your teeth changes. To understand how a tooth decays, you first need to understand what a tooth actually is. The outer layer of your tooth is enamel. It is the hardest biological substance the human body produces, harder than bone. Its structural strength comes from its mineral composition, approximately 96% hydroxyapatite, a crystalline calcium phosphate mineral arranged in tightly packed rods that give enamel its extraordinary resistance to mechanical force. But hydroxyapatite has a vulnerability. It dissolves in acid. Below the enamel is dentin, less mineralized, more porous, and threaded throughout with microscopic tubules that run directly to the nerve at the center of the tooth, the pulp. This architecture matters because the pathway of decay follows it exactly. Acid dissolves enamel first, then penetrates dentin. Then the tubules carry the acid toward the pulp, and that is when the pain begins, not at the beginning of the process, near the end of it. Your tooth can be losing mineral for months or years before you feel anything. The acid producing this destruction does not come from the food itself. It comes from bacteria, specifically from a species called Streptococcus mutans, which may be the most clinically significant bacterium in the human oral cavity. Streptococcus mutans has been living in the human mouth for longer than recorded history. It is a gram-positive facultative anaerobe, meaning it can survive with or without oxygen. It adheres to tooth surfaces using specialized surface proteins. It forms biofilms, structured communities of bacteria embedded in a protective polysaccharide matrix. This biofilm is what we call dental plaque. And here is the mechanism that makes it so destructive. When fermentable carbohydrates enter the mouth, sugars, refined starches, anything that breaks down into simple glucose or fructose, Streptococcus mutans metabolizes them through glycolysis and produces lactic acid as a byproduct. Within minutes of sugar contact, the pH at the tooth surface drops. Normal oral pH is approximately 7, neutral. Below pH 5.5, hydroxyapatite begins to dissolve. Calcium and phosphate ions leave the enamel crystal structure. The mineral density of the tooth begins to decrease. This is called demineralization, and it happens every single time you consume fermentable carbohydrates. Every meal, every snack, every sip of a sugary drink. The critical biology here is timing. After the acid attack, saliva works to restore the pH and redeposit calcium and phosphate back into the enamel. This is called remineralization, and it is your body's natural repair mechanism. The problem is that remineralization takes time. approximately 20 to 30 minutes after the pH drops before the process can begin effectively. Every time you eat or drink something containing fermentable carbohydrates before that window closes, you restart the acid attack, and remineralization never gets a complete cycle. This is why frequency of sugar exposure matters more than total quantity. Sipping one sugary drink continuously for 2 hours does more damage than drinking it in 5 minutes, because continuous exposure never allows pH to recover. Now we go inside the enamel itself. Under a scanning electron microscope, early dental caries looks nothing like what most people imagine. There is no hole yet, no visible damage. What you see instead is a change in the crystal structure of the hydroxyapatite. The tightly packed mineral rods begin to show microscopic spaces between them. The subsurface layer of enamel begins to lose density, while the outermost surface, still in contact with saliva, may appear intact. This is the white spot lesion, the earliest clinically visible sign of caries, a chalky white patch on the tooth surface that most people mistake for staining. At this stage, the lesion is fully reversible. Remineralization, given the right conditions, can restore mineral density to the subsurface layer. Fluoride plays a critical role here. It substitutes for hydroxyl groups in the hydroxyapatite crystal, forming fluoroapatite, which is significantly more resistant to acid dissolution than the original structure. This is the mechanism behind fluoride toothpaste, not coating the tooth, chemically altering the mineral structure to make it harder to dissolve. But if the demineralization continues, the surface layer eventually collapses. The cavity becomes physically open. Bacteria penetrate deeper. The dentin tubules are exposed, and now the pathway to the nerve is open. At this point, remineralization cannot close the lesion. The structural damage requires physical intervention. The decay must be removed and the cavity restored. What began as a microscopic shift in crystal density becomes a dental procedure. There is something happening in 2025 dental research that deserves specific attention, because it may fundamentally change what tooth decay treatment looks like. Researchers have developed a bioinspired gel that can regenerate tooth enamel. Not strengthen existing enamel, regenerate it by mimicking the natural biomineralization process that forms enamel during tooth development. The gel contains amelogen-derived peptides, proteins that guide hydroxyapatite crystal growth during embryonic tooth formation. When applied to demineralized enamel, it templates the regrowth of oriented hydroxyapatite crystals that structurally integrate with the existing enamel. The material is fluoride-free, and in laboratory studies, it forms a mineral-rich layer that restores enamel hardness to levels approaching that of natural intact enamel. This is not yet a clinical treatment available in your dentist's office, but it represents the first credible biological pathway toward true enamel regeneration, not restoration, regeneration. For context, enamel cannot currently regenerate once mature. It contains no living cells after eruption. The ameloblasts that formed it during development die before the tooth enters the mouth, which is why a cavity cannot heal itself the way a bone can. If this research translates to clinical application, it changes the fundamental equation of dental caries management, from drilling and filling a structural failure to biologically restoring the tissue before the failure becomes irreversible. So, what does the biology tell us about prevention? Not the general advice, the specific molecular logic. The first lever is frequency management, not sugar elimination, frequency reduction. Every eating and drinking event that involves fermentable carbohydrates initiates an acid attack. Reducing the number of those events per day, rather than the amount consumed per event, is the single most impactful behavioral intervention the biology supports. 3 discrete meals with no snacking gives your saliva 6 to 8 hours of uninterrupted remineralization time across the day. Constant grazing, even on small amounts, never allows pH to recover. The second lever is saliva function. Saliva is your primary biological defense against caries. It buffers acid. It delivers calcium and phosphate for remineralization. It contains antibacterial proteins, including lysozyme and lactoferrin, that suppress Streptococcus mutans populations. Anything that reduces saliva flow increases caries risk dramatically. Dehydration, mouth breathing. Over 200 common medications, including antihistamines, antidepressants, and blood pressure drugs, list dry mouth as a side effect. If you take any of these medications, your caries risk profile is fundamentally different from someone who does not. The third lever is the oral microbiome. Streptococcus mutans does not operate in isolation. A diverse oral microbiome with healthy competing bacterial populations suppresses its dominance. The same principles that govern gut microbiome diversity apply to the mouth. Dietary variety, avoiding excessive antiseptic mouthwash that eliminates beneficial bacteria alongside harmful ones, and understanding that the goal is not a sterile mouth, it is a balanced one. 3 billion people are currently living with untreated dental caries. Not because toothbrushes are unavailable, not because fluoride does not work, but because the biological mechanism, the acid attack cycle, the remineralization window, the role of frequency over quantity, the specific bacteria involved, has never been explained in a way that connects to daily decisions. Knowing that sugar causes cavities tells you almost nothing useful. Knowing that every eating event drops oral pH below the dissolution threshold of hydroxyapatite for 20 to 30 minutes, and that your saliva needs that window to restore mineral density before the next attack, tells you something you can actually act on. The biology is not complicated. It has just never been properly decoded. That is what BodyCode is here for. Now, before we close today, I want to tell you what is coming next week. We have spent today inside your mouth. Next week, we go inside your head. 1 billion people worldwide live with headache disorders. Migraine alone affects more than 1 in 7 adults globally. It is the second leading cause of disability on the planet. And the biology of what actually happens inside the brain during a migraine attack, the cortical spreading depression, the trigeminal vascular activation, the neurological cascade that produces the aura, the pain, and the hours of complete incapacitation, is one of the most extraordinary and least understood stories in all of neuroscience. Next week on BodyCode, headache disorders, including migraine, the complete biology. Make sure you are subscribed. I will see you there.